Okay, we're going to take a little look here at the mean value theorem. The mean value theorem, if you remember, says that if you have a function that is both continuous and differentiable on an interval, technically just differentiable between the endpoints, there's some point, some x value we usually call c, such that the derivative of the function is equal to, see the slope over here, that is the average rate of change. Physically, on the graph, what this is saying is, and I've shown this picture a whole lot of times in class, but if I had some kind of function, say it looked something kind of like this, if I found the, and again, it's got to be continuous, has to be differentiable, so it's got to be a smooth curve, no cusp, no breaks. But if I found the average rate of change, which is actually the slope of the secant segment, the slope between the starting point and the ending point, there should be some value, and we call that c, such that the derivative has the same slope. In other words, the tangent line has the same slope. So we could say there, that place where that occurs is point C. We're looking for the x-coordinate where that occurs. Now, on this particular graph, it doesn't have to just be one value. You can see we've got another point over here. Didn't draw that very well. We got another point over there where the tangent line also has the same slope as the secant line. And sorry, I didn't make those lines should all be parallel there. But anyway, hopefully you get the general idea. So what's this look like in actual questions? Well, here's one typical type of question that you might see. Hopefully I can get this to load here. Looks like it's loading. Let's see. All right, so they ask us for the value of c that satisfies the conclusion of the mean value theorem for this function. And by the way, all polynomial functions are differentiable, which means they're also continuous. So basically, we need to set the derivative equal to the average rate of change. Okay, well, the derivative here, f prime of x, is going to be 3x squared minus 4x. Okay, and we're going to set that equal to the average rate of change on the interval between 0 and 2. Okay, so that's going to be f of 2 minus f of 0 all over 2 minus 0. F of 2 for this function is going to be 8 minus 8. Oh, that's interesting. That's going to be 0. F of 0 is also 0. Oh, that's interesting. So it ends up being 0 over 2, which of course is just equal to 0. So we've got to figure out what makes the derivative equal to 0. So we're going to set the derivative equal to the average rate of change. Okay, should be able to factor out an x here. So you're going to get 3x minus 4. And you can see in this particular case, x could either be 0 or x could be 4/3. And that's very interesting because you'll notice there that we have both of those as options. So what's going on with that? It does say in the interval between 0 and 2. I believe it actually has to be not at one of the endpoints. It actually has to be one of the values in the middle. So you can see here. Oh, that is tricky though. They were being kind of tricky there. But anyway, 4/3 is going to be the solution there that you get for part D. So that's what's going on with that one. And I am going to do a video on one other one in just a moment.